I'm Kaveshri from the team Codebase. This use case is about AI-powered drug discovery acceleration. In simple terms, the goal is to use AI to predict how molecules behave, how they react with each other, and whether they can become useful drugs. The challenge here is that molecules are very complex and there are millions of possible chemical combinations. So, manually testing everything is slow and expensive. That's why we use AI models like graph neural networks and molecular embeddings to understand and predict these chemical interactions efficiently. My solution is an end-to-end AI pipeline that takes two chemical molecules as input and predicts whether they can form a useful drug. First, I convert molecules into machine-readable formats like fingerprints and graph. Then I use different models, a graph neural network to understand molecular interaction, a toxicity model to filter harmful compounds, a drug classification model to identify the type of drug. Finally, the system outputs safe drug-like molecules along with predicted use. In this project, I personally worked on the core intelligence of the system. I built and trained the ML models that understand chemical data. This includes converting molecules into numerical formats, training models to predict toxicity, classifying drug types, and also using advanced techniques like graphical neural networks to learn how molecules interact. So, apart from the interface, I handled all the data processing, model building, and AI decision making parts of the system. And coming to coding part, this file defines graphic neural network used in my project to understand chemical reaction. Since molecules are naturally structured as graph, where atoms are nodes and bonds are edges, we use GNN instead of traditional models. This model uses two graphic convolutional layers and to learn chemical features from the molecule structure. Then we apply a pooling step to convert entire molecule into a single representation. Finally, a fully connected layer predicts whether reaction is likely to happen, giving an output between 0 and 1. This model plays a key role in predicting whether two reactants can actually form a product. And coming to next file, this code is used to predict chemical reaction between two molecules using a GNN. It converts the input molecules from SMILES format into a graph structure for processing. But molecular graph are combined and passed into a trained model to evaluate reaction possibility. Based on the model's prediction score, it determines whether a reaction is likely to occur. Finally, it returns the product molecules for further analysis. Coming to this code, it is used to predict whether a molecule is toxic or not using a ML model. It converts mild chemical structure into a numerical fingerprints using RDKit. A random forest model is trained on this data to learn toxicity patterns. The trained model is saved and later loaded to make predictions on a new molecule. Finally, giving a SMILE input, it outputs whether the compound is toxic or non-toxic. And this code is used to predict realistic chemical reaction product using a pre-trained transformer model. It takes two molecules, combine them into a single input sequence and process it using a molecular transformer. The model understands chemical patterns and generates possible product molecules. It can return multiple predicted products for the same reaction. Overall, it provides more accurate and realistic reaction output compared to basic or dummy predictions. And coming to this code is actually used to convert a molecule into a graph structure for deep learning models. It extracts atoms as nodes with features like atomic number and bonds as edges, connecting them. These nodes and edges are organized into a format compatible with PyTorch geometric. If the string is invalid, it safely returns none to avoid errors. Overall, it prepares chemical data so it can be used in GNN. Coming to this file, it is used to connect with Google Gemini AI to generate theoretical description of drug usage. It securely loads the API key and sets up access to Gemini model. The system can then use these models to explain how a drug works and its purpose. It helps in generating human readable theoretical insights about molecules or drugs. Overall, it supports adding an AI based explanation layer to your drug discovery system. This code builds a complete AI drug discovery pipeline from reaction to explanation. It first generates possible reaction product using real chemical reactions rules, RDKit. Then it filters out harmful compounds using a toxicity prediction model. Next, it classifies safe molecules into drug categories using a trained ML model. Finally, it uses Gemini AI to explain drug function and suggests its therapeutic use in theory. This code is used to train a GNN to predict whether two molecules will react. It converts reacted molecules in graph structures and combines them into single input. The model learns from labeled data using a loss function and optimizer to improve prediction. Finally, the trained model is saved and can be used later for reaction prediction task. And I have left one. This code is used to train a ML model to classify molecules into different drug categories. It converts mild chemical structure into numerical fingerprint using RDKit. A random forest classifier is trained on this data to learn patterns between molecules and their drug classes. This model is evaluated using accuracy and classification metrics to check performance. Finally, the trained model is saved for future use in drug classification tasks. And let us run the UI part to see a final website. And this is our final output UI for our project. Let us test with an example. Now let me enter the reactant 1 and reactant 2 now. Let us click the run prediction button now to see the results. We can see the predicted output and then the drug class and disease. Let us view the explanation now. And here is the theoretical explanation of this disease. And this is how our website works. Thank you.